Hey, and welcome to this lesson on proving that quadrilaterals are parallelograms. First, let's just clarify the definition of a parallelogram. A parallelogram is a quadrilateral. So a parallelogram is a quadrilateral. Parallelogram is a quadrilateral. However, not all quadrilaterals are parallelograms. And just remember that quadrilaterals are four-sided polygons. Quad means four, and lateral means sides. Okay, so a parallelogram is a quadrilateral with two pairs of opposite sides parallel, meaning that out of the four sides, two of them will be parallel to each other, and the other two will also be parallel to each other, and they are opposite sides. So PQ, if we look here, P and Q, S and R, so PQ, this side, is opposite of SR. They are opposite of each other. They're on the opposite sides. They are parallel. PS is an opposite side of QR. They are opposite of each other. They are also parallel. So therefore, PQRS is a parallelogram. Opposite sides may include arrows to show that the sides are parallel. If the line has the same number of arrows, that means they are parallel to each other. For example, PQ and SR, they only have one arrow. They are parallel to each other. PS and QR, they have two arrows. So now we're going to get into a couple theorems about the multiple ways that we can tell that a quadrilateral is a parallelogram. First, you have the theorem that if both pairs of opposite sides of a quadrilateral are congruent, then the parallelogram, or the quadrilateral, is a parallelogram. So if AB is congruent to DC, and let me highlight this for you, or use my pen tool. So if AB is congruent to DC, and BC is congruent to AD, then I can say that the quadrilateral ABCD is a parallelogram. This is because no matter what, because say for instance DC has the same length as AB, it doesn't matter where this AB is, or if it's straight up and down, or what these angles are, as long as they're the same length and these two are parallel, these two sides will be the same length as well. And vice versa, you can't have these two sides being the same length without AB and DC being parallel. Our next theorem states that if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So, for example, if angle D is supplementary to both angle A and angle C. Just a couple of vocabulary words here. Consecutive means the angle next to it. So D and then A is the next angle. A is consecutive to angle D. If I go to the right of angle D, angle C. Angle C is consecutive to angle D. And supplementary. Supplementary means that the measure of angle D plus the measure of angle A is going to equal 180 degrees. Also, measure of angle D plus the measure of angle A, or sorry, not A, angle C is also going to equal 180 degrees. So because the measure of angle D plus the measure of angle A is equal to 180 degrees, and the same for measure D plus the measure of angle C, therefore the measure of angle A is equal to 180 minus the measure of angle D. The measure of angle C is also equal to the 180 minus the measure of angle D. Therefore, A and C must be congruent, and that means that those two that's a property of parallelograms, that the opposite angles are congruent. And also we can say that D and B will also be congruent because of the same theorem that we just talked about, this theorem, and the fact that all three angles have to add up to 360 degrees. Therefore, this angle has to be congruent to this angle. So, therefore, ABCD is a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Therefore, if A and C are congruent, then it is a parallelogram. Or if D and B are congruent, then it is a parallelogram. And we can kind of prove this the same way we proved the theorem that we just talked about on the previous slide, but kind of reverse it. If these two are congruent, A and C, and B and D are supplementary to A, then because A and C are congruent, they'd have to be supplementary to C as well, and then we could prove that D and B have to be congruent to each other, and therefore it is a parallelogram. So as long as if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So ABCD is a parallelogram. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if I have one diagonal, remember a diagonal is from one vertex to another vertex. A quadrilateral only has one diagonal from each vertex, because the diagonal has to go to a side that is not consecutive to the vertex. And so A, for example, only has one vertex that is not consecutive to it, and that is C. So there's one diagonal there. So if the diagonals AC is a diagonal, and BD is a diagonal, if they bisect each other, meaning there's some point in the middle, so I got that cuts AC in half, so let's call this point P. So AP is congruent to PC, and also DP is congruent to PD, then the quadrilateral is a parallelogram. And last but not least, if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So for example, let's just say DC is congruent to AB and just so happens to be parallel to AB as well. Then we can say that's enough information for us to say that the quadrilateral ABCD is a parallelogram. That's all I have for you for this lesson. Make sure you go try your homework, reach out to me if you have any questions, and be sure to come to live class where we can learn this a little more.